He's just talking to me that he's joining now.
So who will speak first? Mr. Jayantu Basu or?
Both are available, but first Kunal is the speaker, then Jayantu.
Around 68 participants have joined. They are joining slowly.
Kunal is joining shortly, ma'am. Please wait for a minute.
Yes, he is joining.
Hello.
Hello, good morning.
Yeah, good morning, ma'am. I'm a bit sorry to join.
Kunal has joined.
So I'm sorry because I need some time to connect with this software. So now I'm more or less ready. Just I will presentation just 2 minutes. Check my audio.
I will just start the session. Around 75 participants have joined, and
Okay.
they will be joining, I think, slowly. It's only 11:05.
Right. So I will be taking 1 hour for my presentation. I'll just share my presentation first. Presentation to share. Share screen. Share screen.
So, welcome all the participants to the second day of the workshop on artificial intelligence and its applications. I hope you all are enjoying the workshop. It is the first day has been very informative with concepts on the introduction to machine learning and machine translation also. Today we have very interesting topics. We have two speakers, Mr. Kunal Chando and Mr. Jayanto Basu, both from CDAC. Now, before we begin the session, I would like to once again mention that all the participants are requested to follow all the sessions very seriously, because at the end of the session, we will be having an online test which covers all the sessions. We will have questions covering all the sessions. So after which you will be getting your certificates. And another thing, I have also posted a URL, MAKAUT blog ai.blogspot.com. The participants are requested to post their questions, their queries there, and I hope the experts will be answering your queries. So I hope all of you have received the URL. It has been posted in the WhatsApp group that has been formed. Okay, so I think we can begin the session. Now, before I invite Mr. Kunal Chando to begin the session, today's deliberation, I would like to give a brief introduction of Mr. Chando. He has received in 2005 an MCA degree from Besu Shibpur, now known as IIEST. He joined CDAC Kolkata in that very year as project trainee, which followed the role of engineer, senior, and principal engineer. Currently, his designation is joint director and has been working in the image processing section of Advanced Signal Processing Group. He has actively participated in project initiation, execution, and implementation. Also, participation and support in technical negotiation has led to bagging projects. Successfully completed projects under computer vision, namely face recognition and facial expression recognition. Identification of new areas, preparing prototypic versions for demonstration of technologies, and follow-up has led to working in projects on visual, attention, sign language recognition, video analytics, and summarization. He is involved in initiating collaborative projects with top R&D and academic institutes, both in India and abroad, which led to working in prestigious indigenous magnetic resonance imaging project under Digital India Initiative. He has 15 national, international conference and journal papers and 2 patents, both in the areas of face recognition and facial expression recognition. He has also bagged 2 awards in the above mentioned areas. I would now like to request Mr. Kunal Chandra to please initiate his deliberation.
Right. Thank you, ma'am, for that introduction. So I am not complete unless I have my colleagues, Wasif Ahmed. I'll just tell him to wave a bit. He is Wasif Ahmed, principal engineer. Then their project engineers, Sayantan Bhattacharya and Souvik Banik. We form a small group within this ASPG itself, and we all work together to achieve what we have done. And we consider ourselves research engineers coming up with some applications. So I will be discussing most in my presentation on the implementation of these applications in the area of computer vision. I may not be going in depth in the theoretical aspects of it, but I'll try to share our experiences during these years, what solutions we have come up with, the problem domain which we try to address through these solutions, and how ultimately going through that full process of first building a prototype on that particular problem, getting a proposal ready, submitting it, getting it approved, then working on that project, going through those project activities, then development part, then fine tuning, and finally deployment for the respective users. So for this respective applications in computer vision, I'll try to present these. So I'll start off without further delay because I'm already lagging behind. So to come up with the presentation, I'll just share that. Yeah, I think the presentation is being viewed by everyone. Is it okay?
Visible, it's visible.
Okay, so the first application that comes, it's a popular application in computer vision, and my career also started with this project activities on face recognition. In fact, this version is now an older version. The current group people, my other colleagues, they are working on a recent version, which is more into deep learning based architecture. But I had been working on the ML part with the ML algorithms, and where we use this elastic bunch graph matching concept, which used a Gabor wavelet. Gabor wavelets, so what it is, I'll be describing the subsequent slides. So basically, these Gabor wavelets are like filters which are when made to convolve on the facial zone, in particular regions of the facial zone, which are called the fiducial points. There are 14 in numbers on the face, 2 each in the eyebrows, 4 each in the eyes, 1 in the nose bridge, 1 in the nose tip, and 2 in the lips. And when they are made to convolve these Gabor wavelets with 5 different scale of frequencies and 8 different orientations, within 360 degree with 22.5 degrees apart makes 8 different orientations. So 8 5s are 40 filters gets generated. These are made to convolve on this fiducial points to capture the textural features. They form the jets, the image graphs, and the face bunch graphs. Jets are nothing but the 40 features extracted from each of the fiducial points, and they fall into this image graph on the respective fiducial points itself on the face. The stack of the image graph forms the face bunch graph, which is the collection of features from several persons forming a database like structure. So what is this Gabor wavelets? The feature that we have used. It is mainly this Gabor wavelets are biologically motivated convolution kernels in the shape of plane waves, which are restricted by Gaussian function. The expression stands like this. This on a convolving the convolution results from these jets and the image graph to form ultimately the stack-like bunch graph, as I was saying. But what are these jets specifically? To be more specific, these are the set of 40. 5 special frequency, 8 orientations, forming this complex Gabor wavelet coefficient for each of the image points. So for one image point, there is from A1 to A40. Likewise, there for 14 image points, there are 14 to 40, making around 560 such features. Now we need to have a similarity measure with a query phase image. I'll be coming to that a bit later. The phase bunch graph, as I was saying, are the fiducial points located on the face itself, lying on the eyebrows, eyes, nose, and lips. And from there, we form a graph-like structure, but the details are always there from which the phase bunch graph gets generated. But the important point is now with this phase bunch graph that we get, which is a stack of phase graphs for each of the persons forming a database. Now, for one of the person's image taken at another different time, having different sets of illumination condition or certain pose variation, if we happen to capture the facial features or the textual features in the same way, they again form that phase graph. And when we try to have a similarity measure, which is nothing but simply a dot product saying that if it's similar, it's close to 1. It's not similar, it's far away from 1. From that is how we try to capture the best possible matched images. And that is how from the database we try to retrieve for a particular query the best match images. And our result at that time was around 85%, means out of 100 query phases, 85 or something around that figure we used to have that match. But the recognition accuracy needs to be improved. The current version is based on deep learning architecture, which is getting deployed at several of the law enforcement agencies like the Tamil Nadu Police. Then there is NCRB, which we are working on. And next time, moving on, I'll go on to my second application, which is on facial expression recognition. And what is the importance to recognize facial expression? We understand that for communication between two humans, facial expression plays an important role. Voice is one part. The other part is expressing through facial expressions and emotions. So during interaction, this plays a prominent role. So understanding these emotions and knowing how to react with the particular person's expressions enriches that interaction. Now, the problem domain where we found where we can fit this particular concept of facial expression recognition is for children with autism. We well know that autism children, they are emotionally impaired. That is, they are neither able to express their own emotion or neither able to understand the other person's emotion who is standing in front of him or her. So for such person, if we are able to some way improve their cognitive abilities through these affective components means this facial expression or emotional components. Through this week, if we improve their cognitive abilities, that is understanding of this emotional aspect, then some contribution in this field we will be able to achieve. So knowing the user emotion, the system can adapt to the user. Sensing and responding appropriately to the user's emotional state will be perceived as more natural, persuasive, and trusting. In our work, we are focusing on this emotional recognition part. This is based on human-computer interaction-based technology. The related work is our work is based on Ekman's proposition. He mainly went on to capture the 6 basic expressions. In fact, 4 to be more appropriate, which are happiness, sadness, anger, fear. They are facial emotional expressions. Disgust and surprise. We also there between when we're considering disgust. Okay. So these expressions are culturally variable, means what we found is for the Indian context, these expressions have certain meaning. While we had a project with Japanese counterpart with Niigata University in the DST-JST collaborative project, where we had a study on the Japanese facial and emotional expressions. And we found that some of the emotional aspects exhibited by them are slightly different from what we Indian people go on to exhibit. So are everyone able to follow what I am saying?
Yes, sir.
Okay. So as I was continuing to explain, this proposition comes from Ekman, who in fact defines some facial action coding system facts, as it said, on the facial portion. These are 13 in numbers. They are located on the eyebrow regions, on the cheek region, and these are the respective terms which are used for those in the picture beside it. Now, another aspect that comes out is the extraction of the features from here. So mainly we are considering in this area optical flow feature vector as features which are extracted from this facts, that is facial action coding regions on the face, 13 in number, and from there we are deriving the statistical values of mean and standard deviation from it, which are ultimately fed to the classifier. There are several such classifiers also. These are some of the other features which are considered, but in our work, we are focusing on the optical flow feature vectors. This is a facial model where these facial action codings regions are displayed. These are 13 in numbers, as I've said, and from these regions we are extracting these feature portions. This follows the classifier region. There are several such classifiers, and in our work we are considering decision tree classifier. Decision tree basically is a tree-like structure which traverses from the parent to the child node. Ultimately, in the child node, we get a conclusion based on some logic of those statistical features, that whether it falls into the happiness class, or with or in anger class, or in any other class with certain degree of its acceptability. So there are certain problems regarding working with facial images, both for face recognition as well as facial recognition, that is capturing the face region most appropriately. So mask fitting may be one, fitting model may be another, but the most accepted solution is through face detector, and that through with the Viola Jones's exceptional work in this area. The face detector is a fast and reliable one, which is proposed by Viola and Jones. Its main contributions are in the integral image calculation, adder boost, and classify in a cascade structure. Anyone who is working in this area of computer vision are well aware of that. I'll just briefly go through it. This uses basically HAL-like features to recognize objects. Now, in a face, we know if we see the eye region, there is a white, black, white region. There are two such regions in our face, which is a very prominent feature. Like in line features, we happen to get that figure A and figure B in that way. Similarly, with certain orientation also, we can capture those features. Now, the integral images basically is like this, that if we consider for the region A as 1, value 1 coming into that to that point, means all the sum of that values, intensity values in the A region is comes to the value 1, decides on the value 1. For B, it's total region 2 my subtraction of the value 1 region, value 1. For C, it is 3 minus 1, and for D, it is 4 minus of A plus B plus C. Ultimately, to get D, what we can simply do, what we have attained the values in 1, 2, and 3, 4, we simply use those values in that particular expression, that is 4 plus 1 minus 2 plus 3. That is how this integral image helps to have a fast computational aspects. Then there is the adder boost classifier also, which appears in several iterations to capture the most prominent regions in the eye, which have important features lying within it for the such classes. Now, coming to the problem part in a real life problem scenario, which I was saying, for the ASD population, we are trying to address this solution with. Here, basically, we found that there is an ESA-like tool. ESA is Indian Scale for Autism Assessment. They already have this tool through which they try to measure or assess, or rather screen out, if any child has mild, moderate, or severe type of autism. Now, what they do at present is they have a manual form of it. Means they interact with the parents and get to know about the professionals like psychologists interact with the parents. For the parents, they try to understand the child's different aspects, like whether he responds to certain situations, certain stimuli, etc., etc. Now, to convert it into digital form, we had to design certain stimuli and exhibit them to capture their visual attention, their facial expression. I'll be describing the facial expression part here, and the visual attention will be coming into a subsequent work of ours. Now, here, firstly, what we did is we first simply digitized their work, which they do now at present manually. But our work doesn't stop here. We involved a computer vision solution to their domain. So involving computer vision, we understand the first thing that comes up when we use a camera is to understand several constraints, like the environment that this solution is working, or the system is working, needs to understand whether it has proper illumination condition, whether pose aspect is correct, whether there is any noise present or blurriness present there, which we are first computing. This then follows generation of the facial expressions in a graphical form. You see the image on the top. It has a stimuli of a girl showing happiness expression. It's a video sequence. I have a snapshot of it here, and the person below, his facial region got appropriately detected, and from the facial region, from those 13 action units, we are capturing the facial in fact optical flow feature vector, and when we are passing through the decision tree like classifier, we get a happiness expression. So what we are trying to do is for the normal population, we are trying to get this the different degree or intensity values of each of the expressions for particular stimuli within a scale of 1 to 5. Now, when we get a child who is affected by ASD or autism spectrum disorder, we also capture their facial expressions, and we see how much deviation is there from the normal population. In that way, it gives a sense that his cognitive affective ability is certainly has a certain amount of gap, which we will try to improve, and again we will go on through this evaluation process. The below graph shows that in the below graph, out of the three, the top one shows the attentive states. You see there are 3 dips in the top graph, and in the second graph we find that there are missing regions. Means there was certainly eye blinks or certainly things happening of that sort. So it couldn't capture the expression as well as the eye gaze state. So the blue region showed that the vision was saccade. Saccade means it was not focused on the screen, but looking left or right regions. And the pink portion shows that his focus was fully fixated on the stimulus that was exhibited on the screen. The third graph showed the black portion shows the sadness region, or it was the stimuli that was showing that the girl was showing neutral expression there, in fact. But when she go on to exhibit a happiness expression, that time the green bar shows that each of the frames had captured appropriately with a certain amount of intensity or degree of the happiness expression, and went on to display that graph. So this is what we are trying to capture. We are trying to have an estimate out of it so that we can properly give with a score, having a proper explanation of the deviation that I was saying to the psychologist who will be ultimately performing this assessment on the ASD child. Our recent work we are trying to, we have initiated, which is a detection of the emotions based on CNN architecture. The work is still on. We have certain results that we have generated based on happiness and fear expression of our colleagues. WASIF happened to exhibit them. Now, a situation currently prevailing is a new norm coming up, wearing masks. So with the mask, we are trying to capture the face region, and from the detected face region, we are trying to find the pleasant and unpleasant expressions. Here we can certainly get all the 4 expressions because it's difficult to capture, but at least with mask wearing, we can say either in a 2-class problem situation, having pleasant or unpleasant situation, we can certainly capture, because certain most amount of features are present around the eye regions. That is what our assumption is here. Now I'll come to the other application of ours, which is on visual attention. It is for the interactive museum scenario. In this project, we are working jointly with the National Council of Science Museum, who looks after the Science City or museums like science museums in our city, Science City, there is one. Now, there are several exhibits, and currently the practice which is prevailing is whenever a visitor stands in front of the exhibit, there is a certain screen which goes on to explain the exhibit, and it works in a certain loop. It works on continuously without having any particular interaction with the visitor who is standing in front of it. As such, the interest that the visitor doesn't grow up. And we find that there is lack of this interaction, means visit of visitors in the science museums that is happening. But if we make it more interactive, means what I'm thinking, that is what my cognition is in at that state, what I'm wanting to see, if that is explained at that moment, then it becomes more meaningful for me, and thus it holds importance to me also, and my interest also. So that is what we are trying to capture through this work. Basically, in this scenario, we see that a person, when he is standing in front of the front gate of the exhibit room, his face region is captured, and his voice is also captured, so that once he enters in front of the exhibit, that is his face region is identified, and he's welcome, like he's let's say if I'm present in front of the exhibit, it will say, welcome Kunal Chondo, and your preferred language is Bengali, or it may be Hindi or English, and it will go on to narrate based on that language also of that particular exhibit. But what it will go on to narrate, I'll try to explain that. So this is the overall flow of that system. Basically, we are trying to, as I said, through the face recognition kiosk, capture the face region, their name, mobile number, email ID, preferred language. These data are gathered, organized, inspected, and modeled, and go for data processing and stored in an exhibit data bank. Then there simultaneously from the face recognition kiosk also, we exhibit identifies the unit in front of the exhibit also identifies, and it sends a SMS that or in a voice form it says that you're welcome to watch this exhibit. Now there also the face capture happens, data processing happens, and his visual attention as well as facial expression also captured, which I'm going to explain in the subsequent slide. But let's try to understand with respect to an exhibit. This is a diorama that is present. Diorama is nothing but, in Bengali we say during I think during Janmashtami, Jhulon is prepared. Jhulon like thing where there are small idols of gods and of a different day. So it's like that thing that is presented. This is a Mohenjo-daro scenario where people of that time are wearing different attires, where having different utensils, and some scenario of a bazaar is there. So one may visualize the any of the components of this diorama and want to understand what it's going to say. Now the description, it may be explained by a guide who is present in the museum. But if you want to make it more personalized, then whichever he is watching, only that will be explained at that moment. Rather than if in a particular, let's say in a TV set, the description is being rolled out in a loop form, and it may not capture the expectation that what I want to hearing now. So I suppose I have been able to explain the scenario here. Through visual attention, what we are trying to capture through eyeball tracking, we are recording the motion and the duration of each eye fixation. That is where the eye gaze has fallen on that particular exhibit. We are capturing that. We generate a gauze map or the heat map, as I said. I'll be explaining that a bit later. Helps to understand the precise eye movement of the individual with a number of seconds of the eye hung and exhibit element. That is, his eye may be, but his visitor's eye may be fixated at a particular portion also in the diorama. So most attention has fallen there, and more detailed description he may be wanting from there. That is what we want to come out with as an outcome. So the hotspots provides a graphical representation of the behavior of multiple users also. There is one of the expectation. The analysis of the eye fixation with the software allows to interpret exhibit content. So the type of exhibit contents interpretation also here comes out from. This will follow this generation of the heat map. This is shown with the help of an example. In the left portion, you see there is a heat map generated on a particular stimuli. The stimuli shows on the red region, there is a question that is present there, and based on the question, there are certain bar graphs of certain students, which said which student has scored more in this subject than another student. So certainly a person who is seeing the stimuli, his attention will fall, eye gaze will fall mostly in that question region, which is the red regions as it's shown. Then it will fall into the data portion in the bar graph portion there. to answer them. So this is how this heat map also gets generated. This is an example through which I wanted to convey. And the right one shows the timeline series that in which regions, for which span of time, a particular visitor happened to visualize or give time to understand that whole stimuli that is present in front. In that way, we get a sense of the type of content or the content that he is visualizing, how he's interpreting, what is the cognitive state that he is in, to understand the different scenarios in that particular stimuli or the diorama that I was saying, and the outcome will be coming out accordingly. So these are certain other examples to explain the same thing. We try to capture for the user the perceptual speed. Verbal working memory, we are not working specifically in this area, but visual working memory we're trying to capture. How we have not still figured out, but this is one of the parameters we will certainly try to achieve. So the time series that I was explaining is it is basically a series of data points indexed in a time order. It specifically gives which portions after which a visitor has happened to visualize, so that it gives a sense of the order of importance in some way. After all, the overall score will be a fusion of several of the aspects. We can certainly assign weights to each of these aspects. One coming out from the time series also, one coming out from the heat map also. That is how we will be formulating. We are still working on in these regions. This is the heat map, which basically gives displays the magnitude of a particular phenomena in a colorful form in 2 dimensions. The red giving regions showing that more intensity or more eye gaze locations or more was assigned by the visitor on that particular regions. Yellow less than that, green lesser, and blue still lesser. So this gives a sense, overall sense, in which of the regions in a particular stimulus that particular person or visitor has watched. Now let's try to see with an example. This is a Taj Mahal scenario of a Taj Mahal, and there are several aspects to it. One is the 4 minars that they are there. Then there is the frontal region. We have assigned each of the regions, and on each of the regions, like in the next graph, these are the several area of interest that we have, which is the minarets, the chhatri, the finial, white marble, etc., etc. And a person who happens to be in front of this stimulus visualize them, and then goes on to the visual attention goes on to analytics engine goes on to capture which portions he has watched more, and subsequently its demonstration or its description would be coming out as an outcome of it. This is the timelines graph that gets generated. It shows in which of the regions for which span of time a particular person has watched. Then coming to the facial expression part of it, not only through visual attention, but we also want to get a sense in which portion of the exhibit has the interest or the curiosity of the visitor arisen. So this this can be captured through facial expression in a pleasant and unpleasant 2-class problem-like scenario. That is also we are trying to capture. The level of satisfaction on each of the exhibit is also trying to capture, because these inputs will help the museum authorities to further improve on the content part. That is the whole objective here. So this is a typical image processing pipeline where we capture the input image, pre-process them, face detection, segmentation of that area of interest region, feature point extraction from there, data reduction if required, emotion classification into the several 6 basic expression along with neutral also. We try to classify and come out with. The 4th application we are trying to working on is for the mute people, and it is based on sign language. We are in collaboration with Aliajang National Institute of Speech and Hearing Disabilities. For them, we are trying to coming out of the solution a duplex-like communication situation, wherein a normal person who is able to speak in an app will say something, and that will be converted from speech to text and finally to sign language to be displayed in front of the mute person to understand. Vice versa also, the mute person will exhibit certain signs which will be captured through that application and convert into text and finally to the speech part for the normal person to understand. But before coming to that, working on that problem, we found that there exists no standardization although there is an Indian sign language, and such language exists in every country. That is, for America, there is ASL, American Sign Language. For Britain, there is British Sign Language. For India also, there is an Indian Sign Language, and there is continuous research also. But still, no such application has still come out. But we found is in different regions, certain signs exist, which caters to day-to-day needs. And as such, there is no standard sign language corpus which also exists. So first, we wanted to address this part, the part where every people for the state of West Bengal. In fact, we have been sponsored by our state government under Department of Mass Education Extension. They have sponsored a project where we are coming out with an e-learning tool based on Indian Sign Language, which basically based on certain day-to-day words, we are getting their meanings and their sentences in both textual as well as sign form. This we have generated for mobile as well as tablets as well as laptop and desktop, both web-based and desktop-based. We have generated. These are some of the outputs. This is not a computer vision problem, but this is a need to come up for the computer vision problem that we'll be working later. This will help to standardize the signs among all the persons in this community. So this e-learning dictionary we have already, and it's going to be published in public domain by the end of this month. But the main problem here is the sign language recognition part. The sign language recognition involves pattern matching, computer vision, natural language processing, and linguistics. Its objective is to build various methods and algorithms in order to identify already produced signs and to perceive their meaning. What it's going to say, it needs to be identified and conveyed to a normal person to understand. This Indian Sign Language exists and is developed for the deaf community of India, of our country, and it helps to communicate between the friends and families. It is a growing field of research area and is challenging too, because we understand computer vision problems do face a challenge based on the environment that it's working in. Illumination plays a role. Then there is noise and several other inputs which comes along with the camera inputs that there is. There are many techniques which are in existence now, but we wanted to come out with a bare-handed based solution. That is, no devices like wearing gloves or anything should be used to come out to get the outcome or results. These are some of the signs for the alphabets which we need to recognize. So some hardware tools are also attached with it, like wired gloves, stereo cameras, control-based gestures. But we wanted to come up with a simple solution which would be captured through a single camera without any gloves wearing, without any controller systems wearing on the hand. Let's see how much we can achieve. We are still working on the prototype version of this. There are two different approaches. One is the 3D model-based algorithm, like skeletal models, which Microsoft Kinect goes on to provide, from where features can be extracted and then recognized. There is an appearance-based models where from image sequences we can try to capture the features and go on to classify into several classes, like the identification of the alphabets. This is the approach that we have adopted now. We acquire the image, we acquiring the frames in real time. Then we undergo image processing steps like the morphological transforms, blurring, thresholding. Then get the light contour using the convex hull. We try to detect for a particular alphabet its sign. Contour matching, shape matching is performed, and finally the extracted match sign is revealed, what sign that person is exhibiting. Next, I come to the other part. In fact, we work in three areas. One is visual analytics. In the area of visual analytics, we showed the solutions that we have developed in around facial expression, visual attention, and then sign language recognition. There is another aspect we are working, which is video analytics. And there is a final part, which is medical analytics, which I'll be explaining in subsequent slides. In video analytics, we are trying to work on video summarization, and another area which is person re-identification and gait recognition. In video summarization, what we are trying to come out with is a solution where we all know that the CCTV cameras, which goes on to capture and store videos in NVRs, that is network video recorders, 14 days video, after which they are erased off. Now, certain important situations needs to be stored for later references also. We try to address 3 of such scenarios in streets. One is vehicle accident detection and its summarization. One is distress detection, which mostly happens for women in streets. If we are able to capture the distress and somehow can send to the local police station and keep a summarized form of it in the stored portion. That is the second one. Third is the theft detection that occurs frequently in streets and in roads. So video summarization methods attempts to abstract the main occurrences, scenes, or object in a clip in order to provide an easily interpreted synopsis. Video is time consuming to watch also. If we have a whole video, if we want at a particular point of time watch an area of interest only, then it becomes really time consuming to see the whole video and get to the real point. So if we happen to have the real point stored and saved in summarized way, then that already does our job. It is a much low quality video also. Huge increase in video generation in recent years has sufficed to address this type of problem. Specific situations may be previews of movies, TV episodes, etc., summaries of documentaries, home videos, highlights of football games. But our area of interest is in surveillance videos, which are major commercial applications. To understand the video, we all know that a video can be divided into scenes, into shots, into frames. Frames are nothing but a single still image from a video. The frame rate may be 24 to 30 frames per second. Shots are the sequence of frames recording a single camera operation. And scene is a collection of all the shots. That is a conceptual being of the single time and place which gets exhibited. There are series of still images, shot boundary based, perceptual feature based. There is a montage of still images that is in a mosaic form. It may be a collection of short clips or montage of moving images. There are several ways which we can display this summarized video form. Now, coming specifically to the problem that we are trying to address, we are addressing the accident detection part. Here we are trying to address from a particular video sequence or other from a video stream, a point where a vehicle has shown some abnormality based on directional change from its true path, and then goes on to strike another vehicle. So the question we try to answer is, what happens before the accident occurs? What happens when the accident is occurring, and what happens after the accident has occurred? If we happen to answer these 3 questions as stored in a summarized form, then we get a meaningful outcome as a summarized video of that whole scenario. This is what we are trying to achieve here. This is the distress detection part. Here mostly present expression is what we are able to capture. Real live streams we are not able to capture still. We are trying to gather them from different locations or scenarios, so that we can make our engine more rugged in order to capture the distress of the satisfied facial regions of people working in front, moving about in front of a CCTV camera. Then there is the theft detection part, where we are in the first stage trying to capture whether any social distancing violation has occurred. If 2 persons comes very close, we will understand theft occurs or grasping of occurs when any 2 persons comes very close to each other. So we are first trying to capture any social distancing violation has occurred within a group of people moving around. And if that occurs only in those frames, we are trying to capture the grasping portion. The grasping portion is still we are working on, so no such results have still we have obtained. But these are some of the outcomes on the red region shows that people have come very close together within a particular threshold, so that they happen to violate the social distancing norms. The next work that we are trying to do is person re-identification, wherein we will understand that in certain surveillance setup, face regions are not appropriately captured, as is shown in the image here on the right. This person's image is not well captured, so we cannot get proper facial features to identify them. Now, there is another approach that is adopted in this person re-identification problem scenario, where based on appearance-based features, let's say on a particular day, in our office, there are several CCTV cameras installed. A particular person he's a visitor, he's an unknown person. He comes into our office and he moves about in certain regions. And let's say after a certain amount of time, after 30 days or 40 days, we happen to suspect that certain thing had happened in a particular day. And if we happen to go back for that particular day and try to find out in which of the camera locations that a person has roamed about, we get a sense that where he was present. So this basically works based on appearance-based features. Mostly, it works for a particular day. Person coming with wearing a particular dress, then he gets identified. If he comes in a particular another day with a different other dress, he may not be able to be identified for that. But we are still working on creating a more robust model around it, so that how that may also be revealed. We are seeing to it. So this is the problem scenario for person identification. This is the searching part of that video summarization problem, where based on metadata, we are able to retrieve. Metadata means the date or the place, if it is known, if it is provided from the huge collection of summarized videos. We may reduce the search space and go on to visualize that particular video that we are looking forward to. Now imagine a scenario for our office setup. If it occurs for our own employees, our employees visit every day, and if we are able to capture their gait features, gait means the manner of walking, if we are able to capture as features, and if we want to understand based on the gait features where he has visited in particular locations in front of the camera, we get a sense of it. So gait recognition here comes into play. It is another form of biometric technology, and it's non-invasive in nature. We are working on visually based systems that use video cameras to analyze the movements of each body part, that is the knee, the foot, the shoulder, and so on. So what is gait basically? It's the term used for human walking pattern, the way they walk, the movement of the human limbs. What is this gait cycle? The gait cycle is the time period or pattern in between 1 foot of the human hitting the ground and when it's again coming in contact with the ground. This whole cycle is considered as the gait cycle. It has two phases basically: the stance phase, where the phase during which the foot remains in contact with the ground, and there's a swing phase when the foot gets uplifted from the ground and is not in contact with the ground, but till it touches the ground, this is considered as a swing phase. It is a biometric based technology because it is used for authentication based on the physiological characteristics of people. It's a pattern recognition system which establishes a person's identity by comparison of huge data that is stored in the database. Examples of such biometry, we also already know: fingerprint, handwritten signature. Facial recognition, I happen to explain first. Speech recognition, which my next speaker, Joyanto, my other colleague, he will be explaining on that part. And there is the gait recognition that we are trying to explore. So this biometric gait recognition, it aims to discriminate or identify the individuals by the way they walk. Why this biometric gait recognition is required? Because people often feel that they can identify a familiar person from afar simply by recognizing the way the person walks. In fact, you may also have well understand that the people you know, your parents or your brothers or sisters, you have seen them, and after seeing, there is an understanding built in your understanding, in your cognitive abilities, that you are able to recognize, not seeing their face also, by the way they walk, you are able to identify them. So why not try to capture this pattern recognition problem into a particular problem solution? So its application areas are security, medical, sports, but our interest area is in security. It's non-invasive in nature. It's a third-party cooperation not required. High efficiency even over a long distance. It can be deployed in the airports, embassies, banks, military, shopping malls, which are sensitive areas which we will understand. But the problems of CCTV cameras we know are the noise, low camera quality, long distances, and its use is enabling identification even from long distances, identifying association by matching to databases, differentiate the attitude of the person based on the walking style also. Some successful examples are, although the solution is not present, but through gait matching, people of Sweden have able to identify some criminals whose face were not able to be identified because they happen to be blurred by their, but by their manner of walking, they are able to identify these people existing in a particular place or scenario. So there are different sources to capture this gait data: variable sensor, flow sensor, radar, Kinect device, camera. The methodology we use is to identify a person using his gait cycle or stride and achieve this using gait analysis algorithm. There are certain features aspect, high maxima point, which are the initial contact, terminal stance, terminal swing, low maxima points like the mid stance, mid swing, which we are working to achieve. Now, through this pictorial representation, we see these different stages of initial contact, foot flat, mid stance, heel off, toe off, initial mid swing, terminal swing. This we are trying to capture through this binarized images after background subtraction. The workflow is basically the data set which has been created with several features of several people stored in a local directory. We get hold of that. For that data set is set from there. Let's say for a particular person who is walking in front of a camera, a bounding box through YOLO, like we capture that particular person. We do the background subtraction and get the binarized image. From there, we are trying to capture the gait cycle information using the gait analysis, draw points on the gait cycle and plot the graph, and compare the mean of the result with the database. That comparison or the similarity measurement in some way will try to retrieve the nearest matches for a particular image. We are still working on the prototype stage. We have not achieved results still, but once we are able to achieve good results, we will certainly work further in this area. The third area that we are working is under medical analytics, and in the area of medical analytics, prestigious project which is IMRI, we are working on. Here I will request Wasif to explain this few slides. I'll just take 5 minutes a break, and then I'll come out with the last portion. Wasif, just take 5 minutes.
This IMRI project is basically a multi-organizational project where other CDAC center and also some Samir Mumbai and IUSC Delhi are in this project. So here is basically what our objective is to get the raw DICOM images, and from raw DICOM images we have to quantify those images. Means we have to show the maps that are required for the radiologist to actually identify whether is there any abnormality is present in any portion of the brain or in other parts of the body. So yeah, as you can see in the pictures, these are all the raw images, and from the raw images, DICOM images, we happen to generate the ADC maps, that is apparent diffusion coefficient maps. Means in our brain there are some movement of water is there. If there is some tumor or any other abnormality or some stroke there, if there is any restriction of the water movement, we used to generate ADC map to identify which portions are this one. This is doctor actually need to see. And another one, not only ADC maps, also when you're also doctor want to see the directions of the path where the abnormality happens, and by generating the fractional anisotropy maps that you can see in the direction by this in the picture. You can see these are the different directions with different colors, and through the FA maps, and in the ADC and the FA maps both have some values in the particular range, from range 0 to 3 for ADC, and from FA from 0 to 1. If there is any change in the ranges, the radiologist be sure that some abnormality or some irregularity happen in that particular portion, and then they intervene. The neurologist intervene by with any operation, any surgery, or by medicine. So these are the generated maps and some engineering matrices where we have validated our algo generated data with the scanner generated, that is already Siemens scanner, GE scanner, and Toshiba scanners and Philips scanners are there. So we validated our algo generated results with the already the scanner generated results, and you can see in these are some engineering matrix where we generate the root mean square error and the peak SNR, and we see that the results are similar to at par with the scanner. So these are some results, and yeah.
So thanks, Wasif. Wasif has explained the diffusion imaging module. He and Sayantan has been. Are you able to hear? Yes. Are you able to hear?
Yes, sir.
Okay. So Wasif was explaining MRI diffusion imaging part. Diffusion imaging part, and now do next in this area. What we found is, if we come out with an
Sir, your voice is not right now.
yeah, I'm working on it. It's okay now.
Yes.
Yeah.
Yes, sir, yes, sir.
So yeah. So this AI ML based predictive solution is nothing but what we are trying to come out with is now if for a particular patient whose first scan is performed, generating this MR images from the diffusion imaging protocol, generating the ADC maps, the fractional isotropy maps, which gives a sense of if any existence of tumor is present or not. Now, if from the very first scan we are able to predict the type of tumor staging that person is in, if it's in the initial stage or the mid stage or the final stage, if it's able to be captured, then it certainly helps for the patient party, not only in reduction of cost and time, but also on the UJ that the patient goes through. This is a proposition based which this area of radiomics comes up with, which basically refers to the automated quantification of the radiographic phenotypes. Now, this is what the radiologists try to visualize also, and try to predict based on their understanding and study. Now, we can also come up with a digital solution on it. We are not replacing the radiologists here, basically, but what we are trying to do is create a normalized platform for all the radiologists from where they can further continue their observations and explorations. This radiomic data has the potential to uncover disease characteristics that fail to be appreciated by the naked eye. Means if we collect minute features also based on certain algorithms like the gray level co-occurrence matrix and their run length matrix, there are several algorithms based on textual A that we are working on to get meaningful information out of it. Then it happens that that the naked eye sometimes doesn't able to capture those, but it can be captured through our software itself. The central hypothesis of radiomics is that distinctive imaging algorithms quantify the states of diseases and thereby provide valuable information for personalized medicine. This is what we are trying to achieve. And radiomics has emerged from oncology, but can be applied to other medical problems where a disease is imaged. Now, there are several features like the engineering features are hard-coded features which are often based on intensity, shape, texture, wavelet, and LOG features, and have been found useful in several clinical areas as oncology and cardiology. There are deep learning methods also which can learn these feature representations automatically from these data. These features are included in neural nets called the hidden layers. Within radiomics, deep learning involves utilizing convolutional neural nets or convonets for building predictive or prognostic non-invasive biomarkers. The radiomics study refers to building these robust statistical models based on the image processing of MR images and advanced machine learning techniques to improve prognosis and therapeutic response prediction, paving the way for imaging-based precision medicine. Let's understand through with an example. With the high volume quantitative radiomics features, which are captured through multiple parametric MR imaging, that is, it may be through diffusion, through perfusion, through other also protocols that exist. If we are able to capture them, and then for let's say for the tumor, for the prostate cases, the tumor existing in prostate cases, if it can be automatically detected, it provides a plethora of meaningful data, which can be used for both detection and prognosis of the prostate cancer. This automatic prostate cancer detection using a radiomics-driven deep learning framework is now being usually explored in this area or domain. Currently, there is voxel resolution radiomics-driven prostate tumor detection approaches which utilize quantitative radiomics features as shared with individual voxels on an independent basis. There are incorporation of additional information regarding the spatial and radiomics features relationship between the voxels. Voxels are the set of pixels within this medical images. Their relationships, interrelationships are tried to be captured, based on which the tumor type can be predicted. Is what is being tried to be achieved. And these current methods for radiomics driven automatic computer-aided prostate tumor detection typically uses supervised method or learning from this set of low-level features. Then this extraction of three-dimensional texture features from MRIs have been corrected for background inhomogeneity and non-standardness, because this is the heterogeneity is what we are trying to calculate. So this should be appropriately extracted in order to meaningfully classify into several stages. The method that combines structural and metabolic imaging data for prostate cancer detection and detected cancer regions within prostate tissue uses a random forest-like classifier. These are some of the literature explanations that I'm providing. We are working currently. We are trying to create a prototype of this system, because the other part on diffusion imaging we have already completed and validated, as Wasif has explained. This is the new area in AI ML based technology that we are trying to come up with. So this is still a new regions that we are trying to work. So deep learning framework leverages the full set of pixel level quantitative radiomics features and incorporates interpixel spatial and feature relationships to detect tumors more reliably by taking into account the interconnected tissue characteristics reflective of cancerous tumors. This is very important, and this we feel that deep learning framework will be able to come up with what we have studied and found. So firstly, a large amount of quantitative radiomics features are extracted from this MP, multiple parametric MRI, that is different protocols that we are saying about diffusion, perfusion, etc., using a quantitative radiomics feature model. Secondly, a classifier trained using quantitative radiomics features from training data is used to perform this initial pixel resolution cancer detection. Means the classifier will simply be able to classify which stage that cancer stage is. The radiomics-driven deep learning framework is then used to perform final pixel resolution cancer detection using the initial results produced by the classifier and the full set of extracted quantitative radiomics features of the current patient case. In effect, it will try to say, try to predict this particular patient's next pathway would be, so that his treatment can be designed accordingly. This is the overall flow from the multi-parametric MI data like T2 weighted or ADC or DWI. These are names of several protocols. These radiomic features are captured. They are able to be classified, and finally this tumor detection and staging is tried to be performed. These are several of the names of the protocols. I'll not take much time because already I have crossed my time. So this is all about our work. And here I want to express my and my other colleagues thanks to give us an opportunity to explain our work, and hope I've been able to convey what our work is. Yeah, thank you, ma'am.
Thank you very much for this very informative lecture. It was very interesting and very useful for our participants, I'm sure.
Thank you, ma'am.
Yes, because most of the participants here are students, and they are we have postgraduate students of AI and data science here as participants, and graduate BSc students also, intake students also. So these kind of lecture sessions are very useful for them, very informative.
Thank you.
And really, thank you very much. And there are many questions, but I would request you to please stay with us. We have another lecture session, so we can take the questions after the session. Is it okay?
Or you can mail me, ma'am. We will try to, because I have to go back to my other project activities also. So if it's possible to send me the questions, so my email ID, if it's possible, ma'am.
Okay.
Is it possible?
We can take up 1 or 2 questions. Because
okay, right. Okay, fine.
And we will take 1 or 2 questions here.
Okay, there is one question here which I'm getting is, Hamnosis a standard sign language? Has it been taken into research? Yeah, I have this question. I'll try to answer that. This particular participant here has correctly used this Hamnosis word. Now, Hamnosis is not a standard sign language. A standard sign language means like Indian sign language is a standard form, which prevails in our country. Hamnosis is a way of designing those signs. They are a form of a structural way of understanding the several stages of the hand movement, so as to say. Okay, and it is really an active area of research, and we are also trying to adapt this Hamnosis method to identify the particular sign. What I mean to say, let's say I have a particular hand movement. Now these can be divided into several stages, Hypnosis goes on to detect these stages, and then they help in identifying a particular sign. It's not a standard sign language, but helps in development of a grammar of the sign itself. Okay. Another question is, what is ADC and FA maps? ADC stands for apparent diffusion coefficient and FA for fractional anisotropy. Basically, from diffusion imaging, what we try to understand is the diffusion means whether the movement of the water molecules. Here, water molecules means the hydrogen ions that we are trying to capture. We understand there is 70% water in our body, and which exists in the form of hydrogen ions. What their movement is, whether it is restricted or whether it is flowing seamlessly. Okay. Now, for ADC, we consider the magnitude only, the magnitude part. But for FA, that is fractional anisotropy, we consider the magnitude as well as the direction. So when Wasif was explaining, you might have seen for ADC, he showed grayscale images. But for the FA maps, he not only showed grayscale, but he showed some colored FA maps also, which basically showed the movement in different color forms in different directions. There's movement from front to back, from top to bottom, which is shown through several colors. Achha, there is the third question, that is there any work in video content searching? Video content searching, in fact, what we try to convey is we are doing this what is asked here, that is, it is simply content based, that is from the content, there's certain situations like vehicle accident portion, or let's say a theft happening, or distress from a particular person being exhibited. So these are contents which we are trying to capture through certain logic, and we are trying to store, we try to answer some basic questions of that content. That is for vehicle. What I try to convey is how that vehicle happened to get to a situation of accident, what happened during the accident, what happened after the accident. If we can capture those frames and collate them and store, then it becomes a meaningful summarized content form, which we are able to search and retrieve and show at a later time. Someone said about the PPT. I will certainly share my PPT to Hena madam. I already submitted also. You can get the PPT from there. So I have these questions, ma'am, which I tried to address. I think it's okay.
Yes, and there was someone had raised their hand. If you have any more questions, you can raise your hand. We can directly invite you in the panel.
Yeah.
Participants may raise their hands. We also have, yes, Mukund Kumar. Okay, please unmute yourself.
मेरा एक क्वेश्चन है
Yes.
कि इमेज प्रोसेसिंग के माध्यम से जब हम कार्य कर रहे होते हैं, तो अभी मेरा जो एक रिसर्च है, एमफिल रिसर्च, जिस पे मैं अभी काम कर रहा हूँ, वो है टीचिंग को लेकर के, हिंदी टीचिंग को लेकर के एज ए फॉरेन लैंग्वेज। तो मैं उस पे काम कर रहा हूँ, एक कंप्यूटेशनल मॉडल डेवलप कर रहा हूँ, जिसके माध्यम से हम ऑडियो विजुअल अप्रोचेज को जो है वो हम दिखा सके। तो मेरा क्वेश्चन ये है कि क्या हम उसे इमेज प्रोसेसिंग के माध्यम से हम कंटेंट को कैसे जनरेट कर सकते हैं, उसके संदर्भ में कुछ हमें जानकारी चाहिए थी।
सर आप थोड़ा और एक बार अगर थोड़ा एक्सप्लेन कीजिएगा, मैं पकड़ नहीं पाया। इफ यू कैन एक्सप्लेन अ बिट मोर।
सर मेरा जो रिसर्च थीसिस है उसका जो टाइटल है डेवलपमेंट ऑफ कंप्यूटेशनल मॉडल फॉर टीचिंग ऑफ हिंदी एज ए फॉरेन लैंग्वेज यूजिंग ऑडियो विजुअल अप्रोचेज। उसमें हम क्या कर रहे हैं कि एक एंड्रॉयड ऐप विकसित कर रहे हैं, और हम सर्टेन क्या करते हैं, जो लैंग्वेज एम्बिग्यूटी है या लिंग्विस्टिक्स जो पार्ट है उसका, उसमें क्या है कि कई सारे हम मशीन ट्रांसलेशन में देखते हैं कि हमको प्रॉब्लम्स आ जाता है एज ए वर्ब या ऑब्जेक्ट के रूप में, जब हम बाइलिंगुअल या मल्टीलिंगुअल लैंग्वेज के पर्सपेक्टिव में काम करते हैं। बट हमने क्या किया, लैंग्वेज एम्बिग्यूटी को खत्म करने के लिए हमने उसको ऑडियो विजुअल अप्रोचेज के द्वारा जो है हमने सेशंस तैयार किए हैं हिंदी टीचिंग को लेकर के फॉरेन लैंग्वेज के रूप में। बट मैं उसको एक एंड्रॉयड ऐप के रूप में मैं उसको कर रहा हूं। तो बट क्या है कि ये मैनुअली हो रहा है, क्योंकि मेरी बैकग्राउंड लिंग्विस्टिक्स बैकग्राउंड रहा है और मैं कंप्यूटेशनल लिंग्विस्टिक्स मेरा एम में रहा है, क्योंकि मैं कोई बीसीए वगैरह नहीं किया था, तो मैंने कंप्यूटेशनल लिंग्विस्टिक्स एम में किया और एम में मैंने कंप्यूटर साइंस पढ़ा। तो मैं ये सोच रहा हूँ कि जो मेरी, आपने अभी भी जैसे कि बताया कि इमेज प्रोसेसिंग के द्वारा मैं कुछ वर्क कर सकता हूँ, तो मैं ये चाह रहा हूँ कि सर्टेन नॉलेज मुझे मिल जाए कि कैसे मैं अपने चैप्टर्स वाइज को इमेज प्रोसेसिंग के माध्यम से अलग कर सकूं या उसको कुछ इनहैंस कर सकूं, इसके क्षेत्र में मुझे कुछ इन्फॉर्मेशन चाहिए था।
Yeah, but the sense that I get is there is less of image processing here, more of natural language processing and speech processing involved. So I would request my next speaker, my colleague Joyanto, who is into this area, who is into the linguistics also, and I think he will be able to address more to your answer. Computer vision.
Yesterday we had Mr. Vivekananda Kundu.
Yeah, Vivekananda is also there, right?
Because he had lectured on machine translation.
Right.
So what I can suggest you is we have the discussion blog. I was going to talk about that only. We have a discussion blog and the link has been shared with all the participants. So if you have any query, our experts can answer your questions.
Yeah.
So any further questions that our participants may have on yesterday's session or today's session or in future sessions, you can write your queries and the links will be shared to the experts as well. So they can answer your questions online.
Okay, ma'am. Thank you. I will
Yeah, it's
send
okay.
my
It's okay.
on this platform. Thank you, ma'am.
We will take one more question and then we will move on to the next session. Can we operate a mouse pointer with our eye movement? And how can we do that? Will you suggest any resource?
Can we monitor?
Can we operate a mouse pointer with our eye movement?
Yes.
How can we do that? Will you suggest any resource?
Yeah. So this is what we are trying to work for the visual attention project also. In fact, we are using a Tobii like eye tracker. You search with the word Tobii. It's a popular eye tracker device. And but how Tobii basically works is when placed in front of our screen and there is a stimuli in front of our on the screen itself, the eye movement or the eye gaze, it has two types of movements. Either it's fixated or is second. It captures the eye gaze coordinates. And now let's say you have created a visual keyboard like thing, which has several functionalities. The eye gaze that falls on a particular function, based on your logic, it can certainly perform the respective function which that key holds. So certainly you search with the word Tobii. This Tobii eye tracker, when used in your program, you are able to get eye gaze coordinates, and with that you can perform your respective function also.
Yes, thank you. So I think, thank you very much.
Yeah, thank you, ma'am.
For this session. And I think we can move on with the next session.
Yeah, Joyanto is already there, right?
Yes. So we welcome Mr. Joyanto Basu. On the second day of this workshop. I hope, Mr. Joyanto Basu, are you there?
Yeah, madam, good morning. Yeah, I'm here.
So I would like to invite you for the second deliberation of today. And before we begin, I would like to give a brief introduction. Mr. Joyanto Basu, Principal Engineer, is associated with the Advanced Signal Processing Group of CDAC Kolkata for the last 15 years. Mr. Basu received his ME degree in Computer Science and Engineering and BTech degree in Electronics and Telecommunication Engineering in 2006 and 2004, respectively. During this period, he has been involved in wide variety of R&D projects in the area of speech signal processing. Those are speech corpus development, text to speech synthesis, automatic speech and speaker recognition, diarization, language identification, emotion recognition, standardization of IPA symbols, pronunciation lexicon, speech-to-speech translations, which have motivated him towards advanced R&D areas on speech processing. He has been involved in 14 numbers of R&D projects in the above mentioned areas. He has filed 1 patent, published more than 40 research papers in different national and international conferences, and received 4 awards CSI Young IT Professional Award in 2011 and 14, Scotch Order of Merit Award 2014, Mobile or Good Award in 2015. He has guided more than 30 numbers of BTech, MTech and MCA students for their final year and pre-final year projects. He is a professional member of IEEE and IEI. I welcome Mr. Basu once again and request him to please start his lecture.
Yeah, thank you, ma'am, for your brief introduction. So just I like to share my screen. Just a minute. Is it visible, ma'am?
Yes.
There is a sound. I'm just playing. Is it audible to you? The sound. Is it audible to you? I mean,
no, sir.
No, actually, I'm playing some sound. So,
Sir, for that, at the time of sharing, you will be getting the left bottom, share the system sound. You
where?
have to check. So, kindly stop the sharing and reshare.
Okay.
At the time of reshare, there will be a option at the bottom of the left side.
Share
Click on share
screen.
screen. After that, just wait.
Yeah, you can present. Okay.
Yes,
yeah.
sir, yes. Now
Okay, I
you
missed that. Yeah, sure. Oh, thank you. Yeah. Now is it audible? Is it audible now?
Yes, sir. Yes, sir.
Yes.
Yeah, thank you. Thank you for the brief introduction. So today we will talk on AI in speech processing, and so these are the contents of my today's topic. And before we start, I like to play a few audio sample to all of you. And there are 8 audio samples. I would request all of you to listen carefully because most of the audio file is very much familiar of maybe some actress or maybe some politician or scientist's voice. So you need to find out or need to think about the who is the speaker, or what do you think about this audio? I'm playing the first audio as a sample.
कि लहरों से डरकर नौका पार नहीं होती, कोशिश करने वालों की कभी हार नहीं होती.
This is number 1. So just keep your answer in your mind. Second voice sample.
Today's event is about education and technology. More specifically, it is about empowering the students of today to create the world of tomorrow.
My third audio.
We're at an important inflection point in computing, and it's exciting to be driving technology forward. And it's made us even more reflective about our responsibilities.
फ्रेंड्स, ये वो समय है जब टेक्नोलॉजी के बिना जीवन की कल्पना करना मुश्किल है. आज करीब हर व्यक्ति का जीवन टेक्नोलॉजी से किसी न किसी रूप में जुड़ा हुआ है.
Fifth one is,
my administration has accomplished more than almost any administration in the history of our country.
So you may use your power to build walls and keep people outside, or you may use it to break barriers and welcome them in. You may use your faith to make people afraid and terrify them into submission.
Life is not so simple. We have to handle the failures with stout heart.
My last one is,
Chandrayaan was India's first lunar probe.
So I played here 8 audio file of different speakers, and some in different language also, like in English, Hindi and Bengali. My question is there anybody can identify who are the speakers? So I think some of you identify few of the speakers' audio voice. So there is few, photo, pictures of the speakers. Maybe after getting these pictures, you may map your audio, your answer with the audio voice. So there are scientists, there are actors, there are politicians. So, the answer is something like this. So, first voice is Amitabh Bachchan, the actor, Satya Nadella, Microsoft CEO, Sundar Pichai, Google CEO, Narendra Damodar Modi, our Prime Minister, Donald Trump, ex-US President, Mr. Shah Rukh Khan, the actor, and seventh one is APJ Abdul Kalam, the scientist, and also the President of India. And eighth one, maybe we can't map with some known voice. It's not unknown for you, not for maybe not for me, but it's unknown for you. So why I played those voice sample in front of you? So that's because so the information within the speech signal, what I have played, maybe it's related with some speaker information, some emotion of the speech, and the language also very important, because some of the audio file is spoken in Hindi, English, and Bengali also. So if I also identify those languages, speech content is also very much important, because some of the speaker speak in English, but after getting the audio file, you can translate, or you can just speech to text translate, you will get the content. And also if it's a conversation, then also you will find the who spoke when, and there are many other. So I like to say that we are in the researcher of AI and machine learning. We worked on different natural data, maybe the audio data, maybe the stock exchange data, maybe some facial data, or image data, or maybe the IMD forecasting data. So there are many data like this data also these all are the natural data. So but within these all those natural data, in my team we are working in audio data, mostly in the area of the speech signal processing. So I will start with what is speech signal processing. So the speech is basically sound is a mechanical vibration of any gaseous, liquid, or solid medium, and also is defined in many ways. Like a human, we can speak or we can communicate. That's why we generate speech, and animal can also generate speech or audio data to communicate with the others. So there are many standard definitions available in different, like in socio-linguistic, they can say our main communicative intent. So there are, a definition of phoneticians, the acoustician, DSP engineer. For the DSP engineers, I will say it's a digital signal and to be processed. And the pattern recognizer can say it's a pattern to be classified or analyzed. And as a computer scientist, it's a challenge of finding efficient algorithm for processing it. So when we talk about the AI and machine learning, we need to focus on the objective of the problem and need to extract some features and the useful information from the audio data. And we need to implement our application in such a way that it will help to our end users. So what is the speech acquisition? Because it's very important. These is a signal of audio data. So you need to, you need to record, or acquisition is very important, because if you record your voice using your microphone in your laptop or mobile or desktop machine, you will get this kind of time versus amplitude graph. And when we record, it's automatically we need to provide it's an analog to digital converter, because in our computer you can record or store only the digital data, and we need to process all the digital data using A to D converters. So these are the formal presentation of the speech signal, where you will show in the first this is the waveform, where x-axis is the time and y-axis is the amplitude, and is the same audio file I'm showing in the spectrographic view, where the x-axis is the time, y-axis is the frequency, and the intensity. I mean, the more darker is the more intense. It's a power. Power is more intense. This is the more darker is here in this area. The intensity of that location is much higher than this area. Okay. So speech production is a very common because we need to communicate with each and everybody using our audio data. So I'll just there are many components or many things are there. So I'll just show you this diagram where from our lung, using the muscle force, the volume of the air will pass through this vocal tract. This is vocal tract. There is a vocal folds are there, and vocal fold, it's vibrating always. So when I'm talking with you, my vocal fold is continuous vibrating, and it's produce different voice as well as unvoiced sounds. And there is a nasal cavity, I mean nose and this mouth cavity. When I'm speaking with you, some of the voice output is coming from my mouth as well as from the nose also. Because if you can try in yourself, if you just hold your nose tightly and try to speak something, maybe you can produce some audio data, but it's not natural. So both the mouth output and the nose output is very, very important for the production of any speech or audio data. There are different speech events like segmental and suprasegmental. What is segmental? So segmental, first, this is the audio data and time versus amplitude, and maybe this portion is that belongs to do, and this I mean this region is belongs to a. So there are different phonemes when we need to talk. There are different phonemes. Some are consonants, some are vowels. So these are the segments. These are the consonants, and these are the vowel. So we can say this is the unvoiced region, and this is the voiced region, and this is a saw sound. This is again the unvoiced. So there are different consonant and vowels combination, and it produces a sentence. And when we call the segmental, parameters, we will obviously look at the duration of the different consonant as well as the amplitude. Like a amplitude of this ah, it's the higher amplitude of this saw sound. And another way, there is a pitch profile. Is the pitch up and pitch down. There is a pitch profile. So we can say that duration, amplitude, and pitch are the three important parameters for the segmental. When we talk about the segmental, I'm just playing a audio file where John says Peter is liars, that is spoken, but the way of spoken is different. Just listen carefully.
John says Peter is a liar. John says Peter is a liar.
Second.
John says Peter is a liar. John says Peter is a liar.
So I am playing the same sentence, but the intonation is different. So where in the first sentence, it's like a Peter is a liar is conveyed, but in the second sentence, John is a liar is conveyed. So who is the liar? It's depend on the intonation and prosody. I mean, it depends on the pause. Okay. So this is the example of suprasegmental. And prosody difference of different other parameters like speaker gender, age, feelings like anger, sad, happiness, and meaning of sentence like a natural sentence or imperative or interrogative sentence. Prosody like a fundamental frequency, duration, pause. These are the important parameters, and for this the fundamental frequency, duration, and pause may vary. So when you work on the audio data or any speech data, we need to think about the speaker characteristics, feelings, and the meaning of the sentence, because these the parameters can if we can change this parameter, it will give you the different prosody. So there are different applications in area of the speech technology or speech research, like speech recognition, when and speech recognition conversion of the speech to text, speaker recognition. We need to classify speakers with their voice. Language recognition, we need to identify the language. Emotion recognition, we need to identify the emotions of the speakers, like it's an angry mode or it's an anger or happy mode. So what are the mode of speaking we can identify from the speech also. Like my previous speaker, Mr. Kunal, he informed that from the facial expression also we can extract the facial emotions. But in parallel, we can also extract emotions of from speech signal also. So another application is synthesis. It's like a text to speech synthesis, because currently your Android phone, if you see that there is a facility of talkback facility, you can just on your talkback facility, everything on your screen of your Android, it will be read out. I mean, it's a text to speech synthesis application. Speech to speech translation, from translating source language to target language. I'm spoken in English, but you don't know English very well, then you can listen, or we can translate my English into Hindi so that you can listen in Hindi also. And when you speak in Hindi, I can also, it can be translated in English, and it can be listened to me as an output of my English. So, and coding, manipulations, like speech enhancement, voice mapping, there are many applications in this area of speech processing. Today, we will focus on different applications, like what we are doing in SEDAC and what are the trends in this area, like speech processing. First of all, we will talk a little bit on the features, because you know already what is features, because feature is a measure of a property of a speech waveform. The reason of the feature extraction is that we can reduce the redundancy or harmful information we can remove. Well, we can reduce the computation time, and it's easier to model. Speech has many, acoustic phonetics features, like a fundamental frequency, like F0, formant frequencies, formant bandwidths, and there are like intensity, duration. These are all the important features. And not so natural features, like it's a high level feature, we will say that substrum features, linear predictive coefficient, these are the features we need to extract from the audio data. So there are different features for the, like example for the speaker recognition, I'm given here as an example. It's depend on the lexical and syntactic features, as well as it's a low level acoustic features. We need to extract the different features as per our requirement. So whatever I am showing here, these are the features we can extract from the audio data, audio signal. Like in the image processing, you need to find out the pixel values, x and y coordinate, x and y values. In a speech signal, it's a one-dimensional signal, and need to extract those features for our application. So these are the classical features. I mean, these are the parameter or feature classification we need to use for different application purpose, like a filter bank analysis, short-term spectral analysis. So I will not go, in detail to all. So I'll just give you one brief example of extraction of features. Like I have a signal ST, and it's a digitized form is x equal xn. So I like to pre-emphasis first, like yn equal to xn minus alpha cross x minus n. And after pre-emphasis, we will do the framing, because we need to work on the audio data. Those are not in periodic in nature. So speech is like a quasi-periodic nature. So we need to work in frame by frame. First of all, we will work like a 40 millisecond frame or 25 millisecond frame. Then we will just scroll our frame to the next 25 millisecond with a 50% or 40% overlap. So these are the basic mechanism to extract any features from the audio data. Then we will do the windowing. For windowing, we can use the Hamming, Hanning, and cosine window. Then after, we will use the DFT of that particular frame or window. So So we extract the power spectrum from the audio data. So these are the very, very basic steps of extraction of any features. If you work to extract any features, you need to follow these are the steps. And we call it as a whole the basic signal processing block. And after that, we need to extract the different features, the different substantial features. That depends on your application. Next, I will show you some videos. The current research trend, like the worldwide, the researcher like Google, IBM, Microsoft, they are working on different application area in this particular of speech signal processing or audio data processing. So this is a video. Just listen carefully when I play the video. It's a speech-to-speech translation. When one boy and one girl is going for any official discussion, the boy can speak only English and the girl can speak Spanish. And the girl, she don't understand English very well. And the English boy, he also don't know about any idea of Spanish. So just look at this.
Sorry, I'm late. New York traffic.
Me dijo mi jefe que sabía español.
My boss told me you spoke English. Excuse me. Hello?
How's the meeting going, man?
Not good. She doesn't understand English, and I don't speak Spanish.
Get speech trans.
What?
Speech trans. You don't have it yet?
No. What is it?
It's a language translator. It's awesome. Download it now from the App Store right now. Don't blow this.
Don't worry, I got this.
Ay, quisiera que me entendiera. Creo que eres tan guapo.
I wish you understood me. I think you're cute.
The saying goes, business before pleasure, but I think you're cute too.
Dice el refrán, negocio antes que el placer, pero creo que es un lindo demasiado.
Quisiera tomar un trago después de hablar de negocios.
What do you say we get a drink after this?
Sounds good to me.
So whatever I'm showing, it's application of speech to speech and between English and Spanish. So this kind of application is already available in the foreign language. And also you have seen that when we can translate from English to Spanish, the Spanish guy, the girl, then she is more comfortable to speak with the boy. So that's the application like a speech-to-speech translation. Again, I'm showing you another beautiful application. It's a BART language communication. We call this kind of language when the two people can speak in a different way, not like how we are talking. It's not the human language. It's a BART language, but the people can speak in this BART language from hilly region. Just look at the video.
not visible. The video is not visible, Mr. Basu.
Okay. Maybe it's a little bit fast. Anyway, so what I mean to say, like the people in different tribal community, they can speak like how the bird can speak between two birds can speak in a different way. So the people can also speak in the same way for the communication. So the UNESCO, they are working in this bird language, and it's an endangered language. And around only 10,000 people in the world can speak in this bird language. So why I'm showing this kind of video? It's available in YouTube. You can also search. I mean, I request the students so they can also search using the bird language communication. It's a project of UNESCO. So they are working. I mean, they are working in this bird language. So anyway, there are another problem in talking head. So I'm not playing. This is another beautiful, video. It's an animal speech application. So, ma'am, if it's not visible, just tell me. I will close that.
Yes, sir. Yes, sir.
I'm going to show you a new
Hello,
Android
sir, it is not
application
visible.
developed through our translation technology.
Hello.
Yeah, please.
You need to share the not only this screen.
Application. Yes, sir. You have to share the screen. It's the first option.
Yeah.
So please stop the sharing option and start resharing with the option share screen, the top first one.
Screen.
So while sharing the option, select the share screen sound with first option, with first application.
First option. Yeah.
So, you can open the videos.
Is it visible now?
Yes, sir. Yes, sir.
Anyway, sorry. So thank you for your input.
I'm going to show you a new Android application that's been developed through our translation technology. Our new app, Google Translate for Animals, translates animal speech into human vernacular. The handset records the animal sounds and then transmits them to our server, where the speech recognition and translation engines analyze the neurobiological acoustics. The voice recognition software then checks itself against the millions of sounds in our animal linguistic database and produces a translation in plain English. Let's see how Google Translate for Animals works. I activate the Translate app. As you can see, there's a large range of animals to choose from. I choose pig. Then I make a recording. See here, it transcribes it, but if I push the speaker button, we can actually hear what Bella said.
New person. Smells good.
That's amazing. Let's find out what's on Donna's mind.
Love you.
To get Google Translate for Animals, go to Android Market and search Translate for Animals.
So Google is currently working on the animal speech application also. Madam, should I play my previous video?
Yes, please.
Yeah. Just this is very interesting. Is it visible now?
Yes, visible.
So these are the video of Bard language. So you can, I'm taking this video source from YouTube. So there are different organizations, they are working on different aim. Like UNESCO, they are trying to preserve this Bard language, and they are working on this Bard language so that we can know what are the Bard language, because it's an endangered language right now. So there are different other applications in the area of speech and audio data analysis. My part 3, I will try to discuss on the speech technology application, like in CDAC. What we are doing, we are also trying to do something like like on speech synthesis, like we are also trying to do on speech recognition, speaker recognition, emotion recognition in different projects. And also it's a very important to create some resources, because any kind of machine learning application, if you don't have the proper resources, it's not possible to build your application. So we need to create the annotated speech corpus, emotional speech corpus, and IPA symbols for standardized IPA symbols. We need to study on those pronunciation lexicon, because the pronunciation is also very, very important for the Indian languages. So these are the very basic area in where we are currently in CDAC, we are currently doing. There is an application like Bengali text-to-speech, Nepali text-to-speech, and Mizo text-to-speech. I know that in CDAC Calcutta, we are mostly working on Eastern and Northeastern languages. So these application we developed for the, if you type in Bengali or Nepali or Mizo in your computer, that your system, I mean your computer or your maybe laptop can speak in Bengali, Nepali or Mizo, whatever your application. So this kind of application we developed, and we also deployed this kind of application for the visually challenged people in Tripura. So we deployed our application for 2 visually challenged schools in Tripura, and where we deployed our text-to-speech synthesis, as well as we deployed our on-screen phonetic keyboard that will come later. So this is the screen of Bengali text-to-speech. You need to write in Bengali Unicode, and the system will speak in Bengali. Similarly, you can write in Nepali. It's similar like a Hindi also. It's a Devanagari script is used for the Nepali. And also the Mizo text reading system. For the Mizo, they don't have their own script. They use their Roman script as an input. So we need to extract information from the text, and those texts we need to generate in the synthesized audio data. This is the Bengali phonetic keyboard. This kind of keyboard we develop for the visually challenged people. Whenever you will type something on your using your laptop or any desktop, the system automatically spell out. I mean, speak out. This is ka, this is a, this is cha, and after giving you the space, it will give you the proper word. I mean, if it's a correct word, it will spell out the particular word. So these are the very useful for the visually challenged people. So we also deployed this phonetic, Bengali phonetic keyboards for the visually challenged population of Tripura. Similarly, we can also working in other, in languages, but most of the time we need to, in CDAC Kolkata, we need to work on the Eastern and Northeastern languages that I already mentioned. So these are the different on-screen keyboard. There are many on-screen keyboard available on the internet for the, on Unicode, but these are the indigenous development of in CDAC Kolkata. We use this kind of keyboard for different application. So this is another application of speech recognition, and the objective of this work is to identify the audio input, speech of like we work for the Bengali, but different other institutions like IIT Guwahati, they worked on the Assamese, IIT Bhubaneswar, they are working on Oriya. So they're different institutions, they are working on different other languages. Like we worked, it's a consortium project. We worked in different 11 Indian languages. We worked where the farmer just speak with his or her phone and will ask a particular query in the agricultural domain. So it will identify the farmer's input and it will translate speech to text, and it will, after getting the text, it will crawl the information from the trusted Government of India website and provide the information to the farmer. And also we will try to provide the weather information, like what are the weather, also the forecasting information. We crawl the data from the IMD, Indian Meteorological Department, and we crawl the data and also provide the weather information to the farmers. And in Sira Kolkata, we are mainly responsible for the Bengali language. So what we provide, we provide mostly the commodity prices, like a modal price, minimum price, weather information, maximum, minimum rainfall information, and humidity, relative humidity in percentage. We provide to this kind of information to the farmers. So these are the basic architecture. Already this kind of application we deployed in NIC server, where the farmer just pick up his or her phone and dial a particular number, and the system can automatically pick his call, and here the speech recognition system is inbuilt in the server. It will identify the speech data, and it will be translated from speech to text in Bengali in our case. And after that, there are price database and IMD database, weather information database are already there. So we crawl those data and we provide the relevant information to the farmer, because the farmer, they don't have any idea the current market price of different commodities. So the Government of India is trying to provide the relevant information to the farmers. So similarly, we work for the Government of West Bengal, where we provide the similar application like IVR, as well as we develop the mobile app. Through the mobile app, the farmer can get the relevant information. So these are some screenshot of Sufal Bangla, application, where the farmer just select different any farmer as well as consumer can use. You can also download this Sufal Bangla app from Google Play Store, and if as a farmer, as a consumer, you can use those data, because maybe some of you have seen that Sufal Bangla, there are different stores in around the Kolkata and surrounding. You can get the live price for the consumer that is announced by the Government of West Bengal. So these are the live data, and we worked on this data. And also there is text to speech synthesis system is integrated with this application. So those who don't have visually, for the visually challenged people, they can just listen the information. It's possible. So these are the application you can download from Google Play Store, and you can use that. So for the different application, we need to create the awareness among the farmers. So we need to visit different area where the farmers they come to the forum and can ask some queries, and we need to understand their queries, and we need to work with their requirement. So we also visit different fields to understand their requirement also. So this is another important area of speaker recognition using voice biometry. Like Kunal, my previous speaker, he speak on face recognition and facial expression. Like your face is a biometric information, like an iris is another biometric. Like in our lab, in my lab, we are working on the voice biometry. Like if you have my voice is my identity. Voice is a popular biometry. It can be easily obtainable. It's user friendly, and you can access, you can record my voice remotely. So and transmission is also very easy, and the solution is a very low cost solution, and it's required a very small storage. So there are the advantage of voice biometry. But on the other hand, we will say that your voice, it's a weak biometry. So why weak? Because if change in cough and cold situation, maybe if there is a network noise and channel mismatch, your voice quality may be different. That's why it's a challenge. So there are many challenges to work on this speaker recognition. There are many features, like whatever we developed we call is a closed set identification and verification technique. It's a text and language independence, less interactive time, real-time usability, support real-time environment, and also if you are cooperative in nature, our system can easily identify your voice. We are working on different other challenging area in this application. Already this kind of application we deployed for the defense establishment. Also we work for the election commission for this kind of application. So these are the different application: access control, transaction authentication, monitoring, information retrieval, forensic investigation. So these kind of application of voice biometry is very, very important for this kind of applications. And these are the system overview. Like currently we are talking about the AI and ML application. So whatever we need to say that we need to first record the audio data from the speakers. We need to extract features. We need to train our system because the computer, they don't understand the actual audio data. So we need to train the data, and we call it the supervised learning. It's a supervised learning. So after the learning, if any unknown data we faced, we can extract the information, and we can say who is the speaker. So it's possible. So these are our application. So another I also mentioned that corpus development is very, very important. In the very long back, we have started working on this corpus station. Whatever currently I'm showing, it's a translate. It's a Bengali, Assamese, and Manipuri corpus we have collected is around in the year of 2007 and 8. So this kind of standard benchmark database is very, very important for your data, for your research. So this kind of corpus is available from the Ministry of Electronics and Information Technology. So you can freely get this kind of data for your research purpose. So in CEDA Kolkata, we have a state-of-art instruments for different analysis, like WIN EPG system, where we need to, there is a custom-made palettes is required for the WIN EPG system to identify the place of articulation of different consonants using this kind of application. When we worked for the International Phonetic Alphabets projects, we procured this WIN EPG system to identify the place of articulation as well as manner of articulation in different way. So there are EGG system, electroglottalograph. Using this electroglottalograph, there are two electrodes. It will put in your vocal cord in your throat, and we can extract, we can easily get your vocal cord signal easily. And there is a nasal system, nasometer. We will say that this is a nasometer, how nasal your sound. So how much your nasal cavity is using, at the time of production, we can also measure using this nasometer. So I will just brief you some case studies because there are different, students are there, maybe graduate student, postgraduate, and PhD students, scholars are there. So maybe this kind of case study is useful. You can also try to work. So we worked on different Northeastern languages for different language identification. So there are 8 states in our Northeast India. And there are many languages the speaker can speak. As per the very old 1971 census, there are more than 220 languages. In these 8 sister states like Arunachal Pradesh, Assam, Meghalaya, Manipur, Mizoram, Nagaland, Tripura, and Sikkim, there are more than 220 languages in this region. And some of the languages we call the tonal language, like in Mizo, the 2 tones like a high and low, 2 tones are there. And Bodo, there are 4 tones like high, low. These are the tones is related to the F0, fundamental frequency. So same word, but the different meaning. If there are, like in Chinese also, there are, it's a tonal language. There are 5 tones. So same word in different meaning. In Nagaland, there are different languages. Just I will give you some sentences. In some of the languages, they don't have any script. Like in Bengali, we have the script. In Assamese, we have the script. But in different other languages, they don't have any script. They mostly use the Roman language. I mean, Roman script. So there are different voice samples. Like I will play for you few. Like in Nagaland, there is a language called Sumi.
Near is block Jilang Ocheni near room number lobdi na lobdila you roommate Sulika Asumishani
So I'm just playing Assamese, you can understand.
Kan lagi movie no ko ye jot.
Hello, তোমাৰ নাম কি আছিলে?
মোৰ নাম অভিজিত শইকীয়া।
অভিজিত শইকীয়া, তুমি ক'ৰ পাছ কৰা?
মই জেইচি পৰা পাছ কৰা।
যোৱাট ইঞ্জিনিয়াৰিং কৰিলা ন?
হয় হয়।
তাৰপা এমটেক ক'ত
So
কৰিলা?
this is the conversation between two speakers in Assamese speakers. So we have collected those data for our research purpose.
নেক্সটলে আহিবলৈ ইন্টাৰভিউ দিছিলো আৰু পাই গলো।
আৰু বেলেগ
we worked for the different Nagaland languages, and we have seen that different vowels of this Nagaland language, they are, the duration of the vowel is different. So we worked of the acoustic analysis on these Nagaland languages, and also we also find out this formant frequencies, like a first formant versus second formant. It has been observed that the different language they are located in different region in F1 versus F2 plane. So using this information, we can tested the unknown data of different Nagaland language, and this kind of confusion matrix we have received as an identification application. So there are some overlap of different language because the Nagamese is overlap to Ao Lutha, because Nagamese is one of the common lingua franca in Nagaland. So it's overlapped with Ao Lutha. So this kind of case studies we have done for our study. So the students, they can also choose this kind of application or this kind of case studies for their research. So another way, we also worked on the emotion recognition. We worked for this German data. This German data is freely available. You can download from this EmoDB database from the website. So we worked on this data. So and also we worked how the emotion and how the language is important to know the emotion. So I just playing one or two wave file.
Das will sie ja Mittwoch abgeben.
In German. I'm playing again.
Das will sie ja Mittwoch abgeben.
Happiness.
Das will sie ja Mittwoch
abgeben. The same
abgeben.
sentence, the speaker speaking in different emotion. But I think this is a subjective evolution. None of the listeners in my center, the German, they don't know the German language. But whenever we evaluate this German database only by listening, the most of the time the listener can identify the anger is very well. Like anger, most of the time the people of the listener can identify the anger as an anger. But it's a little bit confusing of happiness and the fear. Like currently I'm playing the happiness, but sometimes the happiness the listener can identify as an fear. This kind of application and this kind of experiment we need to carry out to evaluate the German database. Similarly, we have also extracted information using different classifiers and features. We use the GMM, also use the SVM and MLP, machine learning algorithm, multi-layer perceptron to identify the emotions. So this has been done. Some of our students they use the VQ and GMM as a classifier. This is the Bengali some example. I can also play if you just. It's a fear. So if you see the happiness.
Hippie hooray! আমরা পেয়ে গেছি।
Intensity of the happiness is different with the fear. So if you worked on the, if you extract the information of the intensity and the F0 contour, you can also a little bit, identify the emotion also. Anyway, this is a similar kind of stimulus we developed for our application. The same sentence, like a key bully to you, what are you saying in English? The same sentence can speak in different way. in
কি
happy
বলিতে
mode. It's
কি বলিতে
so we need to create this kind of corpus for our experiment. And also we have done the subjective evaluation, and these are the results for the subjective evaluation. And there is another case study of telephony speech data for the speech recognition application. These telephony speech data analysis is also very important, because you know that for the speech recognition application, there is an acoustic modeling and language model is there, and we developed this SAD, a signal analysis and decision module, as a pre-processor of the our speech recognition engine. What it has, this module actually analyze the input audio data, and it will try to identify this audio data is okay or not. I mean, is there any input, any noise within this audio data, or any problem of the channel problem, like noise is there. So this signal processing in the noise model, actually decision model, is actually identify the input data. So we use the very simple, three parameters. So we extract the zero crossing, we extract the short time energy, and also we extract the different Forman frequencies. And these are the different signals, like we call it the truncated reject, because if you see, this is the input of the signal, but it is automatically truncated. Okay, the actual data is not here, it's automatically truncated. We call it the truncated reject. And there's also the silence. There is no audio data, there is an entire silence. We can extract, we can identify this kind of audio data automatically, and we can say that user can say again for the application. So this kind of different analysis we have done using signal, zero crossing rate and energy parameter. So this is very important slide for the researcher. There are different speech recognition, automatic speech recognition toolkits available. So you can use, or you can download these toolkits for your research purpose. If you are interested to work on speech recognition, then HTK, Finks, Kaldi, these are the very important tools you can download and you can use. Although there are Microsoft Speech API is also available, so you can also download those API for your purpose. Google API is also available, but it's free version is available maybe for 30 or 40 days. After that you need to pay, but fast 1, 2, 3, I mean HTK toolkit, Finks, and Kaldi, these are the open source toolkit, so you can download and use in your own purpose. And next step, this TTS toolkit, festival speech synthesis, and HTS based, there is also deep neural network based speech synthesis system is also available. You can download, you can install, and you can also modify as per your requirement. That's the beauty of these toolkits. So I request all the students or researcher, they can download this kind of toolkit, and you can just create your own application on top of this toolkit. So there are different futures research scopes are there, that currently in CIRAC Kolkata we are working on low resource and zero resource languages, because as I already mentioned that in CIRAC Kolkata we are working on the eastern and northeastern languages, and most of the languages are low resource as well as zero resource languages. So we need to try to digitize and preserve those language, and try to develop the different algorithms, AI ML based algorithms on top of using those database. Also there are different challenges on create the large vocabulary continuous speech recognition in different Indian languages. More intonated speech synthesis is very important. Like whatever the synthesis system we have, it's intonated, but there are more chance to provide more intonation. Robust voice biometry is a very challenging. Already we developed the proof of concept, the system of voice biometry, and already deployed few of our client location, but there are lots of scope to work on voice biometry. Also, the language and dialectical variation is very important for the Indian languages. Like, in India, there are more than 1,600 languages, spoken languages, and only the 22 are the official languages. It's a really challenge for us, for the Indian researcher, to work on the Indian languages and dialectical variations. So these are some pictures of workshops we have created in Shantiniketan, Vishwabharati, and some workshop in NIT Silchars. These are the team of Arunachal Pradesh. We worked with the team of Nearest. Assam University, there is a good team with us. And there are different collaborators, like we collaborate with University of Tokyo, Japan, NICT Japan, and also the different national collaboration. Without the collaboration with the different institution, it's not possible to work on this very, very challenging area. And also there are different stakeholders, like MeitY, Ministry of Electronics and Information Technology, and different other stakeholders. So these are our lab members. All the contribution of all members is very much acknowledged. Without their collaboration and without their help, it's not possible to work on this area. And this is our entire signal processing group. Like Kunal is here. This is myself. So this is the entire signal processing group. We are working in different areas like image and speech processing. So that's all from my side. We need all of your cooperation, because without the students' cooperations and without the research on this area, it's not possible to work on this challenging area. So this is my contact details. If you need any information, if you have any question, you can mail me. So you are always welcome. So that's all. Thank you. Thank you, madam. Any question, please?
Yes, thank you. Thank you very much. Very interesting session with lots of interesting case studies and practical ones, in fact. You had explained one app from Google, the pet translator, the animal translator, which is specifically very interesting. Like, where is it available? Is it available?
It's a Google solution. It's a animal voice translation. Currently, the beta version of this app is available, but I don't think so. It's currently available in Google Play Store. But because Google is currently working in this challenging area, because the resource creation of this application of the animal voice recognition is very, very important, because the resource person identification is also very challenging, because we need to identify, we need to train our model, we need to align our speech data with the textual data. So this is a very challenging task. The Google is currently working, and their beta version they have released for the particular use. I don't think so it's a full version is available. So maybe you can check. I will also check.
Yes. Really, it's quite interesting. Okay, so thank you very much, and we have some questions also.
Yeah, please.
Let us go to the question answer session. One question: if I want to use voice biometry, what are the unique features that we have to extract?
Yeah, so in the voice biometry, there are many features, I will say, like our fundamental frequency, like this is our vocal fold, and using my vocal fold, when I am speaking, my fundamental frequency, F0 contour, is one of my unique features. Like for the male speakers, that fundamental frequency is around 100 hertz to 120 or 130 hertz, and for the female speakers, little bit higher, like a 220 230 hertz. And for the child case, for who are the children, around the 300 to 400 hertz. So that are the very unique features. But apart from the fundamental frequency, that formats also played an important role, as well as we extract the different cepstral features like a MFCC, male filtered cepstral coefficients, LPC, linear predictive coefficients. These are the different cepstral features we need to extract from the audio data. I have only one slide here. I have shown that how we need to extract those parameters in a frame by frame, because speech is a aperiodic signal, and we will say that it's a quasi-periodic in nature. Some portion is in periodic in nature, and most of the consonants portion is the aperiodic. So we need to focus mainly on the vowels or the voice region, so that we can extract the important features for the voice biometry. So I will say the fundamental frequency, one of the important parameter of voice bimetry application.
Another question. I would like to ask about the open source speech data that we will use for research purpose.
Right. Yeah, there are many speech data is available. Like I mentioned that EmoDB, the emotional German database available. If there are English data, emotional data is available. So if you just visit GitHub and other like Google websites, there are many foreign language data is available like English, German, Spanish, Chinese. So you can work on those data. So if you are interested to work on Indian language data, I will say that Ministry of Electronics and Information Technology, there is a division, TDIL, Technology Development for Indian Languages. So there is a provision to download the Indian languages corpus. So those who are interested to work on Indian languages like a Bengali, Hindi, Gujarati, Marathi. So there are, I already mentioned there are 22 official languages. So the TDIL, Technology Development for Indian Languages, this group under Ministry of Electronics and Information Technology, they created a data repository. So where as a researcher, you can just mail to them and you just mention your requirement. The MAIT, Minister of Electronics, they will provide a link you can download from the data, India languages data from their link.
Is there any work in speech to sketch converter that can help investigators to identify the criminal face?
Yeah, actually it's possible, but in our lab we are working to speech to text. So if the text processors, those who are the working on the text processing, so maybe they can, it's possible. First of all, the question is very interesting. It's possible, but in our lab we not working directly to speech to sketch, but there is some steps like a speech to text conversion using speech recognition, then text analysis. The most of the computational linguistic they can extract the information from the text, and some sketch may be generated automatically. It's possible. Yeah. And there is another question, what is IPA on-screen keyboard? Is IPA actually the international phonetic alphabets? Like when we present our language, like Indian language in different foreign country, we not to write in our Bengali or Hindi in Devanagari script. We need to write in a IP, international phonetic alphabets, because if we each and every consonant and grapheme, they have the unique symbol internationally. If you search Unicode of IPA in Google, you will get a sheet of Unicode symbol of IPA. So we need to map like our O or our A. So what is the IPA symbol of O or A for Bengali? Maybe for the Hindi is different. So Hindi IPA symbol is little bit different from the Bengali. So it's depend on the pronunciation also. So when we present Bengali data or Hindi data in foreign, conference or in different forum, we need to, use the IPA, International Phonetic Alphabets. It's another alphabets for internationally known alphabets.
We have Tuhin Paul. I think we can directly let him in. Can you just let him in and allow him to talk? Tuhin Paul.
Yes, ma'am. Praveen Mondal, please unmute your mic. And if you have the question, please ask directly. Praveen Mondal.
Yeah, his question has been answered, I think. Tuhin Paul.
It's acquired in translation animal to its. Yeah, I already answered that. Like, so Google is currently working. I mentioned you can also search in Google and YouTube. You will get a little bit more answer, elaborate answer. Yeah.
Hello, sir.
Yes, if you have anything specific to ask.
Yes, sir. Sir, I just wanted to ask that the translator that a few minutes ago you were talking about, that the animals language to humans native language. Sir, is there a need of someone that who knows the language of animals and will
Yeah,
guide?
at least some kind of interpreter is required to understand little bit. Like a meaning is very, very important. Like it's not like a speech to text conversation. It's not possible, but the meaning, the sound and meaning is very, very important. If any child cry, so mother is the best person can understand the reason of the child cry. So so that's why the mother can interpret the child reason of the child cry. So similarly, any animal, when they can speak or they try to communicate, someone or somebody should be there so that they can interpret the meaning of the conversation. So that's a very important. So I mentioned that resource person of this application area is very, very important.
Sir, that means that a lot of data will be required for feeding the
Yeah,
machine.
lots of data, but it's not like it's a huge data. But because right now Google is working on some specific data. Okay, it's like I have only like 20 phrases. I know only the 20 phrases. So the Google is currently working like a 20 to 25 or maybe the 30 phrases and try to give you the proof of concept. Try to implement the proof of concept. The proof of concept is very, very important, because without proof of concept development, it's not possible for the researchers to go forward. So currently the researcher, they are working on the very specific data, maybe the 2 or 3 animals, not animals, many animals, but the 2 or 3 specific animals. Like a pig, maybe they have collected the pig data for maybe 3 or 4 pigs from a farm.
Thank you, sir.
Another question from Shurjodev Manna. Is there any chance to convert thought to speech for those who can't speak?
Yeah, I have another slide. I just skipped that slide. There is a, we call is the silence speech recognition. So if I have a chance, I can just play that also, because it's possible. Yes, it's possible. Currently, it's. I'm just showing you another slide. Sorry. So I just hide this. This is another video. Is it visible, ma'am?
No, not yet.
Okay.
No, sir.
No problem, no problem. Just need to check. Share screen. So is it visible right now?
Yes. The slide
Okay.
is visible.
Yeah, silent speech translation.
Alter Ego seeks to increase human intelligence and make computing, internet and machine intelligence a natural extension of the user's own cognition by allowing a silent, discrete and uninterrupted conversation between the person and the machine, explains the team behind the portable device. In the center there is a new peripheral that mounts on the face and neck. That allows you to track the electrical signals in the facial muscles and vocal cords. These so-called electrophysiological signals are created when the user intentionally and silently expresses words. The MIT team compares experience with when children learn a language for the first time, and how words sound mentally to understand them. The alter ego sensor collection can trace that process in a non-intrusive way. The goal is to develop a laptop companion that can communicate naturally to humans.
So there are different applications. So it's possible. Currently, the researchers they are working on this application also. So any other question?
Yes, there were several students raising their hands. We also have Dr. Aftabuddin with us, our information scientist. Can you please unmute? Can you also share your views regarding this workshop?
Yeah.
Yes.
Good afternoon, everybody. I am also here to learn. So I find it very informative and very good for the students and as well as for the researchers also. And as this is very informative and those people who are working in the field are giving their insights. So it's just not theory or something like that. I get it something beyond that. And yesterday also and today, what I find it's very much informative and uh, just we are getting that in future. These things are will be the bare necessity. There will not be something like that we learn it just like we learn that many things we learn, but we don't use those many algorithms and all those things. But if in this field or for general people also, these things will be the for modern or future of the humanity. Why those things, if you think that for animal speech or animal language or for image processing, you get those medical things. Those things are in already is in use. But uh, for our future students or students, they will have to improve this just like nothing or just like anything, so that this can be used in daily life. This is also, I think this is being used, and I find this workshop is will be very useful for the students. And I also thank the organizers including me and those participants and all who are resource persons. I find each one of them has very good insight in this. Thank you, all of you.
Yes.
Thank you, sir.
Yes, each and every session are really very informative. And
Yes.
yes, and had the sessions been a little more, if we had got a little more time, then it would have been more beneficial. Like 1 hour is not sufficient.
Right.
So maybe one session, one lecture session a day for at least 2 hours would have been better.
And also, ma'am, like a hands-on session we can also arrange online also. Like I have few slides also hands-on session, like in my last FDP program or I mean for the student also we organize like hands-on session. Like if we provide some good amount of data and also provide the extraction procedure, they can just play with those data, and there are some predefined techniques are already available. So those who are the learner, they can just play with those data and the algorithms, so that they can feel that, because speech is a different area of the research. It's a very challenging research area. So if it's we can add it's a little bit on hands-on session, it will also add benefit for the students.
Yes, we can have hands-on sessions also. Like we can continue, we can also plan another workshop with these hands-on sessions.
Yeah.
In this workshop, the students will get an idea, a basic idea on
Right.
the kinds of applications, and in the next workshop, they can have this hands-on session. We can definitely organize it. Maybe you can give some project also and some sort of idea or some project to the students, and they can come up with some solutions, their own solutions if they want to. Maybe some idea, some basic idea.
Yes, there are lots of research scopes, and each and every year the students from different university and college, they visit SIDAC and they interact with the team. So they can also work on the real project. I mean, live project, they can also work, and they can also contribute to, I mean, develop some small algorithms or classifiers. They can also design. So it's possible, ma'am. So already with the MAKAUT and SIDAC, they're working together. So you know that it's possible. all of the students are, and also you are, every time it's welcome to CDAC, to visit CDAC.
So I think we have a few more questions. If anyone wants to ask directly, you can raise your hand.
Right, you can ask or you can mail to the organizer or to the directly to me, so I'll try to answer the question.
One last question we can allow. Mukund Kumar, we are allowing him. This is the last question.
Okay.
Yes.
Okay, thank you, मैम. सर मेरा क्वेश्चन ये है कि जो फील्ड लिंग्विस्टिक्स है, फील्ड लिंग्विस्टिक्स से जो हम डाटा कलेक्ट करते हैं, तो कंप्यूटेशनल फील्ड के पर्सपेक्टिव में हमको क्या क्या सावधानियां बरतनी चाहिए? क्योंकि मैंने फील्ड लिंग्विस्टिक्स में काफी काम किया है 2-3 लैंग्वेजेस पे, जैसे बैगानी लैंग्वेज पे वर्क किया है और गाडिया लोहार जो दिल्ली में मैंने नेशनल लॉ यूनिवर्सिटी के लिए काम किया है. तो हमने क्या है कि जितने भी लेक्सिकल है या फिर उसके भी जो भी उसके जो भी ऑडियो है उसको मैंने कलेक्ट किया. लेकिन मेरी एक क्वेश्चन ये आया जब आपके सेशंस को देखा कि जब हम रिसर्च कर रहे होते हैं और डाटा कलेक्ट कर रहे होते हैं तो कंप्यूटेशनल फंडामेंटल्स के दृष्टिकोण से हमें क्या-क्या सावधानियां बरतनी चाहिए?
Actually, Mukund, data collection and audio, I mean, there are two types of data we need to collect from the field. First of all, the textual data and the audio data. So whenever we will collect that textual data, we need to interact with the people and need to understand their, I mean, alphabets and everything, like words, we need to collect some words, that's okay. But the audio data, whenever we need to collect, we need to take some precautions. Like these audio data maybe we need to preserve in future. So we will say that you can collect the audio data using your Android phone is okay. But if you carry a laptop and a good microphone, like we will say that noise cancellation microphone, and it will cost around 2,500. But it's a very much helpful to collect your audio data. And these audio data can be useful for different aspects. You can use those data for your research, like if you have to analyze those data, acoustic analysis, it's possible. But if you can use to for different other applications, like a speaker recognition, speech recognition of that particular language, those data is very important to learn the system. I already mentioned there are different toolkits are available. So if you have the good amount of data with less noise, those data can be useful to train your model. And you can, reuse those speech data, audio data for your speaker recognition, for your speech recognition is possible. But in most of the computational linguistic aspect, I have seen the students, they collect some audio data in the dash recorder using the some smartphone. There are so much noise because the intention and the objective of the computation linguistics, students of the objective computation linguistics different. So the different is something like that. They need to word only this is the text and this is my audio file, and these phones are available in the text file, and these are the audio data. There is same phone file or similar phone files is available. But when we need to extract the features from those audio data or those samples, then we need to take some precautions. We try to capture the signal in higher sampling rate. Like if I will use 16 kilohertz as a sampling rate at the time of data collection, then it's a good. Most of the time the students, they collect the data using 8 kilohertz or less sampling frequency. So I will request to all of you to collect the data, audio data in higher sampling rate, at least 16 kilohertz, and also use good noise cancellation microphone. And also you can try one toolkit as the PRAT, P-R-A-A-T. P-R-A-A-T. PRAT toolkit, it's an open source tool. Using this tool, you can collect the audio data in very useful way. So I will request to all the computation linguistics, those who are working in the field, they can use PRAT tool to record your data and analyze your data. So Is it okay?
थैंक यू सर। और सर मुझे एक थोड़ी सी कहना था सीडेक से कि हम जैसे कंप्यूटेशनल लिंग्विस्टिक्स बेस में हमने आए, मेरा एमए कंप्यूटेशनल लिंग्विस्टिक्स रहा और एमफिल मैं अभी कर रहा हूँ और मेरा जो फिल्म स्टडीज एंड फिल्म मास कम्युनिकेशन भी मेरा पर्सपेक्टिव रहा है। तो एक मैंने ये चीज़ देखा है कि अभी जो इंडेंजर्ड लैंग्वेजेज प्रोजेक्ट है जो 7 यूनिवर्सिटीज स्टेट यूनिवर्सिटीज यादवपुर में भी चल रही है और 7 सेंट्रल यूनिवर्सिटीज में चले, ये प्रोजेक्ट पे जो है लैंग्वेज पे काफी ज्यादा काम कर रहे हैं और बनस्पत मैं असिस्टेंट प्रोफेसर था इंदिरा गांधी नेशनल ट्राइबल यूनिवर्सिटी अमरकंटक में। तो वहाँ पे इंडेंजर्ड प्रोजेक्ट है, तो प्रोफेसर दिलीप सिंह सर के साथ मैंने कुछ बैगानी लैंग्वेज पे काम किया। मेरा मेन आप सीडेक से कहना है कि जो इंडेंजर्ड लैंग्वेज है वो डाटा कलेक्ट कर रहे हैं, उसको टेक्स्ट को रख रहे हैं, ऑडियो को भी वो रख रहे हैं, परंतु उसका टेक्निकली मतलब टेक्निकली किसी फील्ड से जुड़ाव नहीं हो पा रहा है। तो आपका जो संज्ञान था कि इंडियन लैंग्वेज में हम काफी कुछ काम कर सकते हैं, तो सीडेक इंस्टीट्यूशंस के साथ या खासकर इंडेंजर प्रोजेक्ट के साथ कुछ कर सकते हैं। जैसे मैंने नेशनल लॉ यूनिवर्सिटी दिल्ली में था, तो मैंने उनको कहा कि सर आप इस पर जो है मशीन ट्रांसलेशन बनाइए इंग्लिश टू ये गाडिया लोहार लैंग्वेज। गाडिया लोहार सर एक कम्युनिटी है जो नोमेडिक कम्युनिटी है, तो वहाँ पे हम लोगों ने लैंग्वेज किया, तो हमने कहा कि इसको हम कर सकते हैं। पर जब बाद में आई तो मेरा क्या है कंप्यूटेशनल जो एल्गोरिथम है वो कमजोर है, क्योंकि मैं कोई एमसीए वगैरह किया नहीं हूँ, मैं तो कंप्यूटेशनल लिंग्विस्टिक्स पढ़ा, तो मैंने कंप्यूटर साइंस पढ़ा। तो टेक्स्ट टू टेक्स्ट तो हम कर देंगे, वर्ड टू वर्ड तो हम फंडामेंटल्स बना ले रहे हैं। तो मुझे ये हमें वहाँ हाथ बंधे हुए महसूस हुए कि कंप्यूटर साइंस वाले फील्ड लिंग्विस्टिक्स में आते नहीं हैं। फील्ड लिंग्विस्टिक्स या कंप्यूटेशनल लिंग्विस्टिक्स वाले जो एमटेक कंप्यूटेशनल लिंग्विस्टिक्स किए हैं बीटेक के बाद, उसके लिए तो ठीक है, लेकिन वो बहुत कम है, इंडिया में करीब करीब नहीं है। हम लोग क्या है कि कंप्यूटेशनल लिंग्विस्टिक्स किए हुए हैं, कंप्यूटर साइंस पढ़े हुए हैं, लेकिन जो कंप्यूटर बैकग्राउंड है या उसके जो आर्टिफिशियल इंटेलिजेंस है, नेचुरल लैंग्वेज प्रोसेसिंग का फील्ड है, वो जानते बहुत बेहतर तरीके से है, लेकिन वैसा कोई माहौल नहीं मिला है। और उसमें एक सीडेक बहुत अच्छा है, जैसे महात्मा गांधी अंतर्राष्ट्रीय हिंदी यूनिवर्सिटी से सीडेक ने बहुत पहले एक एमटेक कोर्स चलाए हुए थे, बट वो फाइनेंशियली कुछ ऐसा तक बंद हो गया। तो सर मैं सीडेक से कहना चाहूंगा कि कुछ ऐसा होना चाहिए जिससे कि हम इंडेंजर्ड लैंग्वेजेस को जोड़ सके, इंफॉर्मेशन टेक्नोलॉजी को जोड़ सके और हम जो है कुछ अच्छा काम कर सके। क्योंकि मैं डाटा कलेक्ट कर रहा हूँ और मुझे कोई समझने वाला नहीं है रिगार्डिंग कि हमने कई जगह डॉक्टरल रिसर्च के लिए भी किया, लेकिन हम जो परसेप्शन लगते हैं तो जो हमारे स्कॉलर हमारे जो गाइड होते हैं उनके पर्सपेक्टिव ही नहीं होते इसमें, तो मुझे उनको समझाना बहुत कठिन होता है कि मैं क्या हूँ। वो कंप्यूटर के दृष्टिकोण से मुझको जस्टिफाई करते हैं, हम लैंग्वेज के दृष्टिकोण से उनको जस्टिफाई करते हैं, फिर बात नहीं बन पाती है। जैसे कि अभी हम महसूस कर रहे हैं कुछ कमियां, जो आपको खुद लग रहा होगा कि हम क्या महसूस कर रहे हैं। और ये सब आप लोग खासकर सीडेक बहुत अच्छा काम कर सकता है। इतना अच्छा काम जो नॉर्थ ईस्टर्न लैंग्वेजेस के लिए हुआ है, चाहे आपने गुवाहाटी के बारे में बताया या फिर आप जो कैलकाटा में किए उसको लेकर के किया है। लेकिन आप ट्राइबल फील्ड में आप जाइए, जैसे बैगानी है, गोंडी है, अगर आप नोमेडिक कम्युनिटी में चले जाइए तो प्रोफेसर रमेश चंद्र शर्मा सर जो दिल्ली लिंग्विस्टिक्स के हेड थे, उनके साथ मैंने सपेरा लैंग्वेज पे काम किया उधर दिल्ली के सेंटर में, गुड़गांव सेंटर में। तो हमें लिंग्विस्टिक्स को जोड़ नहीं पा रहे हैं सर, ये हमारी है। थोड़ा सा इस पर देखिए अदर इंडियन में या फिर अदर सेंटर जो है सीडेक के, उनके पर्सपेक्टिव में। थैंक यू सो मच सर, और मैम को खासकर धन्यवाद कि आपने मुझे समय दिया लास्ट क्वेश्चंस में भी। बहुत बहुत धन्यवाद।
Mukund, just a few sentences I need to say. Like, look, this webinar or जो conference जो चल रहा है अभी workshop, so the organizer, I mean MAKAUT and CDAC, they are jointly organize this kind of workshop only because of this reason. Because you are coming from the computational linguistic backgrounds, and there are different students. They are coming from IT, computer, electronics, different engineering background, as well as you as also welcome. So I also like to mention at least in multilingual computing area like speech or NLP, it's a multidisciplinary section. In my lab also, there is a linguist, MA in linguist, she is working with us. So in NLP team, there are 2 linguists, and they are working with us. So because we need the input from the linguist, because without the input from the computational linguists, we don't have any right position to say something. When we talk about the IPA, so it's a completely linguistic project. But as a scientist, as a engineers, we will just understand their requirement and try to implement in AI ML platform. So whatever you mentioned, so I request Mukund, you can touch with SIDAC, you can touch with the organizer so that you can also benefit it in future. So anyway, thank you for your input. Thank you, madam.
Thank you very much. Thank you very much for answering the questions. On behalf of the organizers, I would like to thank Mr. Basu also for sparing time from his busy schedule to be with us. And so with this, I think we can close today's session. I would also like to thank all the participants for joining us. I hope you are enjoying this workshop. And I would also like to mention that we have shared the discussion blog link with you. So any further queries or any kind of discussion you want to have within yourselves or with the experts, you can. We will share the link with the experts, and we have shared it with you as well. So you can continue this discussion even after the workshop sessions, and even after the workshop ends, you can continue with it. So this is, there is a feedback link given to you. You can fill up the feedback link. And so this is all for today. Thank you all.
Thank you. Thank you. Okay, bye.